All right, so continuing on, since this is business calculus, we're going to kind of look at some calculus techniques or things. And in calculus, the tangent line is defined using secant lines and the concept of limiting value as the input approaches a constant. Okay, so this relationship between secant lines and tangent lines is going to be illustrated starting here, then we'll move over here and do some more. And what we're going to do is if we take a secant line from like P1 to T and we draw it through, that's going to give us a slope, which is going to be, our A rock. Then we can move it in and do a P2 a little closer to T, and we can get another one. And if we think about how that tangent at T slope is, every time we get closer and closer to it, we're going to get closer and closer to the same slope as T until we get right up next to it. And then it's going to basically, we're going to come to the limit where we're seeing the slope of the Pn to that T is going to be the same. And that's approaching it from the left. And now what we're doing here is we're approaching it from the left and from the right. So we're kind of looking at it both ways. And as you see, from moving from point 1 to point 2, we're actually drawing those secant lines from the point to the tangent. And as we move closer, that secant line has a slope that's closer to that tangent because the solid line is a tangent line. Now, if we'd moved into, say, point, P, 25 up here, that's going to be really close to the same as the tangent. And if we have P in, it's like right next door, it's like infinity close to that T, what's going to happen is those are going to end up being the same slope as we get closer and closer. As we move from the left towards T, that's going to get to be basically the same slope. Same thing happens as we move in from the right. So remember, if we come in from the left, we can get a limit at a point. Well, it's the same things happen here. We're looking at the slope as we get closer and closer to that point, and those slopes are going to end up being the same because we keep moving up and it gets closer, and the next one's going to come down like that. It's going to get closer. The next one's going to come closer. And so then our slopes are going to be ending up being the same coming from the left or from the right. All right, so that slide was already I had changed it, forgot to delete it. So what this is now is we're looking at that notion of the the slopes coming from the left and the slopes coming from the right. So when we come from the left, we get that slope of the secant through the px and t. So as xn approaches the x from the left, so when we're coming in here, we're coming in and we're getting really, really close from the left, then that's going to give us the slope there. Now, what we have now is that's going to equal our slope of the graph at t. Now, also coming from the right, we saw the same thing. That slope of the secant through p of x and t, as we get closer and closer to our t, it's going to give us the slope of the graph at t. Now, what does that mean? That as limit of x sub n goes to x, the slope of the secant through p sub n and t is going to be equal to the slope of the graph at t. All right, so we'll leave it at that and we'll come back in a little bit for some more.